Hi all, this is Mr. Yeager for chemistry. We are now looking at molarity. So we are now getting into the solution math, okay? What are we going to have to calculate out? This is something to please take your time on, all right? Like I've told my students multiple times, for whatever reason, solutions seems to be a struggle for students. And I don't know whether it's, again, after going through stoichiometry and some of these other units, that there's a letdown during this. This math is not as complex, not as step-oriented as stoichiometry is, where so many students do so well. So please just follow along, find that rhythm that you see that I have with it, and work through these problems, okay? So there is more math. We're going to separate out the math by each video. There's going to be basically this video, you're going to see a dilution video, and then a mass percent and volume percent video. These are all of the different ways we're going to calculate out concentration. This is the primary one, though. Okay? So what is concentration? Concentration is a measure of how much is actually dissolved. All right? Again, solubility is measuring the maximum amount of concentration you can have in it. That's what solubility is referring to. So we don't always get to saturated solutions. So we just need to figure out what is the concentration of the solution, and there's a way to measure that. And so, as we already stated, that we have what's called concentrated versus dilute. Concentrated means it has a lot of solute in it. Dilute means there's not a lot of solute in it. Okay? So that's what we got going on there. And the primary method or unit we use to calculate concentration is what we call molarity. And as the name implies, the mole is back. Okay? And it says it's a ratio of the moles of solute in a solution relative to 1 liter per solution. Guys, very simply, it's moles over liters of solution. Moles of solute divided by liters of solution. The symbol for it is big capital M. The unit is also capital M. So this is one of those things that people get mad about when I mark them wrong. You're going to be writing like M equals 2.5 M, okay? Because this is just the symbolic form of molarity. This is the unit for molarity, all right? And we have our formula. Guys, you will see in a moment how I try to help students deal with this formula, okay? It is pretty straightforward to deal with. We do have a couple steps that we might take into account with it. Okay, I want to mention that already. So what you're about to basically see me do is if you get a molarity problem, one of the first things I want you to do is basically just write out the formula but leave space for numbers. So you're going to write big M equals moles over liters. Now you're going to do that because while the first couple problems are probably going to be pretty easy where I give you moles and liters and you solve, there are additional steps to this. I don't have to give you moles and liters all the time. More commonly, when we make solutions in real life, which you're going to be doing in the lab, is you're going to be measuring out the solute in grams. Well, do you see grams in moles over liters? No. But how can I convert from grams to moles? I use molar mass. So the grams is going to change to moles. Okay? What you will also possibly have to do is change milliliters to liters. You need to remember that 1 liter is 1,000 milliliters, so you're going to usually have to divide that by 1,000. Okay? But this is where I have some people that are like, I don't know where to put anything. I'm so confused. I'm like, get a grip on yourself. Okay? Moles is on top, liters is on bottom. Write it out. Hey, you're given grams. Change those grams to moles. Milliliters, change to liters. Plug it in and solve. Okay? This is also useful. That is also useful if I give you different things and I say go back and solve for moles or solve for grams. Okay? It can help you organize what you got to do. So here we go. Look at that. We start right off with grams. Perfect. So you have 16 grams of O2 gas dissolved in 2 liters of water in a fish tank. Calculate the molarity of the oxygen in the solution. So here we go. So I would write big M equals moles over liters. I'm solving for the molarity, so I'm solving for this number over here. Okay? I am given liters 2.0, so that's already filled in at the bottom. I'm given grams. Grams is not in this equation, so I need to change 16 grams of O2 into moles. I come from grams, I go to moles. That's all we're going to have to do. You're not going to have to keep on going. This is not going to be a stoichiometry. All right? If moles and grams are together, 1 mole, O2 is 32, 16 times 2. So this is equal to 0.50 moles of O2, keeping the sig figs. So this would then be 0.50. 0.50 divided by 2 equals 0.25 molar. And that would be your answer. All right? So setting up my equation makes it very clear. I'm solving for molarity. I have the liters. I need to change grams to moles using molar mass, and I plug it in and solve. All right? Some of you are like, oh, it's not that tough. When you start practicing through it, I'm hoping that is true, and we don't sit there and make some bad mistakes. All right, calculate the molarity of 1,270 grams of K3PO4 in 4 liters of aqueous solution. So I write out molarity equals moles over liters. I'm given liters again, so we're being pretty nice right now. We're not dealing with the milliliters, okay? But I'm given grams. I changed the grams to moles. I do need to calculate this one out. I got moles on top, grams on the bottom, 1 mole. 39.1 times 3 plus 30.97 plus 64. This is 212.27 grams. So 1270 divided by 212.27. I'm getting 5.98 moles. Again, following my sig figs for now, 5.98. Over here, I'm going to round down to 2 because of the liters. So 5.98 divided by 4, I'm getting 1.5 molarity. So what am I saying? There's 1.5 moles of K3PO4 for every liter of solution. All right? And this would actually be a fairly high concentration. Okay, when you're above 1, it's a decent concentration. All right, here's one where we got to change both. I'm solving for molarity, moles on top, liters on bottom, okay? This time I'm given milliliters, so I do need to convert milliliters. So it would be milliliters, milliliters on the bottom, liters on top. 1 liter is 1,000 milliliters. So this is 0.25. So 0.25 liters is on the bottom. For the moles, I'm in grams, 23 grams of LiCl. Grams on the bottom, moles on top, 1 mole. Getting 42.39. This comes out to 0.54 moles. 0.54 moles on top. 0.54 divided by 0.25. I'm getting a molarity equals 2.2 molar. I hope you get an idea. I mean, this is the standard one. Now, we haven't had to rearrange the equation, but this is the standard where you're solving for molarity, grams changes to moles, milliliters changes to liters, solve. Solve, solve, solve. All right, let's find one where we change it up a little bit. Oh, I think here we go. Okay, sorry, this was just confusing me just because we didn't get a chemical. Okay, but we can do it. All right, so I write out molarity equals moles over liters. Okay, I'm given liters, 0.50. This one I'm given the molarity is 1.0. I'm being asked for grams. Well, based on my situation right now, I can solve for moles. I can solve for how many moles because I have the other 2 numbers. So this is what I mean of how we might have to rearrange or solve it a different way. If I want to solve for moles, all I have to do is multiply out the 0.50 on both sides. So I multiply both sides by 0.50. So that means I have 0.50 moles. That's how many moles I need, 0.50 moles. Now, away edits don't like this one as much because it doesn't get, I like it when they give you an actual compound, but saying, there's your molar mass. So if I have 0.50 moles of this substance, and I want to go back to grams, I go moles on the bottom, grams on top, and it's saying 25 grams per 1 mole. So 0.50, this would technically come out to 12.5 grams, but I'd have to round that to 13 grams for sig figs. Okay? So this is a classic, how much do you need to add? This is going to be what we usually ask in labs. Teachers will sit there and go, I want you to make this concentration, this much solution, and you have to go back and calculate actually how much of the solid that you need to get. So this is an excellent, excellent problem to show how to prepare solutions. This is what we as teachers do to prepare your solutions for your labs. All right. How many grams of carbon dioxide dissolved in 0.25 liters of 0.5 molar? So let's check this one out. Again, guys, it makes it easy if you always write out the formula and write in what you have. 0.25 and 0.50. You should not get this confused. This is not moles. It's big M. So I can solve for moles on top. Multiply 0.25 on both sides. I get 0.125 moles. Technically 0.13 moles. Okay? And it says I want to change, this is moles of carbon dioxide. So I now need to change that over. 0.13, let me try it again. 0.13 moles of CO2. Moles on the bottom, grams on top. 1 mole, 44.01 grams. 0.13 times 44.01. I'm getting basically 5.7 grams of carbon dioxide would have to be dissolved. All right. Hopefully you've seen the rhythm. Set up the equation, identify what you're solving for. Moles goes to grams, grams goes to mole. That's going to be, that extra step is the one that we just got to keep making sure we do. All right, I'm not going to do this one. This is basically the same idea. All right, I want to do this one once just so that we don't make a bad algebra mistake. That's so many, this is like the worst algebra I see, the most common error in so many years of teaching that students just really seem to struggle when they're solving for something in the denominator. Okay? All right, so we have 85 grams of LiCl and it's 8 molar. So I write molarity equals moles over liters. If you didn't hear me, I just said molar. A lot of times we just shorten the word molarity to the word molar, like the tooth. Okay? So we would say this is an 8.0 molar solution, okay? Or you could say molarity solution. So we know what the molarity is, 8.0. It wants you to solve for volume. So I don't know the denominator here. I don't know moles, but I have grams. So I'm going to change 85 grams of LiCl into moles. 1 mole, I forget what this is, 6.94 plus 5.45. This is 42.39 grams. 85 divided by 42.39. Let me try it again. It's probably the same thing. I'm getting 2.0 moles. All right. Please watch. Okay? If you watch any of my physics videos, I've gone over this too because it's absolutely incredible how terrible students are at this. You're solving for the denominator. If you want to solve for the denominator, the first thing to do is multiply it out. Do not divide the 2 over. Multiply x out. So you're going to multiply both sides times x. I now have 8x equals 2. You can say 8.0 equals 2.0. I'm now going to divide the 8.0 to the other side. X is equal to 0.25 liters. All right. There you go. There's all the different examples of molarity problems in terms of how they could be arranged, how they could be solved. Just write out that molarity formula. Grams goes to moles, moles goes to grams. Go from there. All right? It is something that can be very, very good and repetitive over time if practiced. If you're solving for volume, please multiply it out first. Multiply it out of the denominator and then solve. Okay? That's it. Very, very good.